Okay, this video is on a very old worksheet that I gave long time ago before our last class quiz before PA2, I think. Okay, so it's a very old one. Later I'll send you uh, the worksheet. Okay, some of you might have forgotten how it looks like. Okay, it's on chapter 11, 10 and 11, I think. Okay, so this particular question is on chapter 11. State the values between which the principal values of cosine inverse x must lie. Alright, so I think we've been revising principal values the past few days. Okay, so this was what we've been revising. Range of values means there will be inequality. When you see this word range, right, it's not like only one answer lah. It can be the answer, right, for this can be ranging from minus 90 to minus 89, minus 70, 0, all the way to 1, 2, 3, 4, 5, all the way to 90. That means it can fall anywhere within this range. And I've explained to you the one-to-one function already. So this is just to recap, alright? And you have here in radian mode, then this is how you should present it, okay? Yeah, so that is, let me focus a bit, what like that. Okay, now if it's cosine, then it'll be like that, okay? Why? Because cosine, right, if I go to the negative section, it will not be a one-to-one anymore. So that's why it is here, okay? Wait, I don't know why it's flickering. I hope it's not flickering for you. Okay, I think can already. Then now, if I go tangent, again, it's from minus 90 to 90 or minus pi over 2 to pi over 2. But note the difference, it cannot include this value. Oh, it's wrong, terrible. This is wrong, right? This is sine, okay? Sine inverse. This is not the shape, so what should the shape be? It's something like your cubic graph. Remember your Emax cubic graph. So want to turn, like want to go maximum point, then turn like that, but then it changed its mind, then it went up. So it's like something like quarter of an egg, okay? So that is how we draw the tangent graph. These values are correct, but the shape, can you see the shape? This one is supposed to be like that for tangent graph. Don't draw like that, it's a very common mistake. Okay, I hope that clarifies. And for radian mode, then it be like that. Okay, for angles in radian, then be like that. Okay, let's come back to this particular question. State the value. So very simple. This question doesn't require you to do any calculation. Simply state, like your science, state the law of whatever. Then just state. Finish. That's all. No? Okay. But if they ask you to find the value, later I'll show you. Okay. Find the exact value of this. Then it's different already. So when they say find the exact value of this, there's only one value. There's only one value. That's why it's a one-to-one function. Meaning later I show you how to do this. Actually, all these questions they will always say without the use of calculator. They will say like that, without the use of calculator. Now, does it mean that you cannot use calculator? Of course not. You should use the calculator to help you get the answer or to check your answer. So how do you use the calculator? Very easy. You just press sine inverse. Sine inverse, right, of minus square root 3 over 2. And then you will get, how you get this? Oh, by the way, we use radian mode, okay? Because they want in radians. But because they want exact value, this is not exact value. How? When they say exact value, it means that this value is in terms of pi. So I'm teaching you how to use your calculator to write in terms of pi. You know that this is something pi, right? Something pi. So remember, you go and calculator is your best friend. You go and divide by pi, okay? You shift, then you press this button, the pi one. So you take your answer divide by pi, you get minus 1/3. Meaning to say, you know already, the answer actually is minus 1/3 pi. Alright, but because they say without the use of calculator, right? So you just put up a show that you know what's going on. Okay, you let this be this. So sine x is actually this, right? So those who still remember, right, the finger thing, sine is the bottom part, right? When will it be square root 3 over 2? When you close this first finger, right? Then it's square root 3 over 2. Remember, this is the cosine. C come first, then S, right? So square root 3 over 2. Yeah, that means it's actually pi over 3, right? Because it's 60. Isn't that what the calculator showed us just now? Yeah. Ayo. There. Minus 1/3. But why is there a minus there? Then you put up a show, right? You put up a show for them to see. You like that. Tell them that you know what is sine inverse x. Okay? This one you just see. This sine inverse actually is your x, right? So it's actually minus square root 3 over 2. That means it's a value somewhere below the x-axis, right? Then you will cut here, 1-to-1 function, you'll cut here. Oh, that means the angle must be negative lah. Correct or not? Because when you use your hand, your finger, you know that already what is 60. 60 is pi over 3, right? But it has to be minus pi over 3 because you will cut the graph here when this is actually your x like that. Okay, so you follow this one has to be a negative value because it's on the left hand side of your axis here, vertical axis. Okay, so what do I have to write as a final answer? That's all. And what does it mean? It means that A, S, T, C, which quadrant is it in? 0 to minus 90, right? 0 to minus 90. Is it here? Here sine is negative, right? It cannot be here, if it's here, then it's wrong already. You know that the range of values for sine inverse is from 90 to minus 90, right? But cannot be 90 here. Cannot be here. Because if it's here, right, it will be positive. The sine of this angle will be positive, correct? So it has to be here. Are we clear? So that's all. Okay, next one. We are still on this topic, okay? Because your end of year exam, right? They won't test you on a lot of things. They won't test you on double angle. Then you ask me what is double angle. Okay, let's see. Wait. I am trying to show you the formula sheet. Okay, sorry for the delay. Okay, now you take a look. Okay, question 2 years ago, 3 years ago. Okay, this is the AMATS formula sheet, right? They will only test you on this. Yes. This one, yes. This one, no. Don't have this. So, don't have this, 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 don't have this. Wow, very happy. Thanks to COVID. Yeah, COVID, right? Very nice to you. So they do know how many discount they give you not? One, and then down here there are actually three formula. 1, 2, 3. So 1, 2, 3, 4, then 5, 6, 7, 8. Wow, discounted 8. So 8 actually 11, right? 11 of these identities they only test you these 3. Okay? So because they got nothing else to test you already, right? because they got nothing else to test you already, so they will test you all this, because because you learn all this, but this topic we did very badly for the class quiz, remember? Of course you don't remember because the paper still with me. Why the paper still with me? Because I want to do a re-exam with you. Because that topic very badly done, so we have to do re-exam, okay? When will we do it? This coming week, Okay, this I don't know whether you still remember. We learned this. Remember? I throw one stick inside here, throw it into the mouth. Will you be able to swallow? No, you throw it back out. I throw one stick inside this. This cosine is like the monster, the cosine root and monster, right? Will you be able to eat up the stick? Yes, the monster. Only the monster can eat up the stick. The other sine and tangent, they cannot eat up the stick, so they'll throw it out. Alright, simple. Then the other thing you need to know is when you have an angle here, x, right? This is 90. This must be 90 minus x, right? So these are the cases whereby the pi over 2 minus x, right, is actually referring to this other angle if it within this triangle, this right angle triangle. Okay, so when you have such things, sine of this is the good friend cosine. Cosine of this is the good friend sine. Tangent of this is the inverse of this tangent. Okay? Now, you will normally, if the examiner is nice, will just give you straight away like that. If not so nice, then what you will do to test you, right, will be they will give you sine instead of 90 minus x, which is this angle, right? They will say x minus 90, but cannot what? X is smaller than 90, so how can minus 90? Cannot. So what you do is you actually not say cannot lah, but you have to take out the minus. That means you rewrite, do make up. You take out the minus, then 90 minus x. 90 minus x can. Big 90, but 90 is bigger than x, right? 90 minus x can. You get some answer, right? Okay. So what do you do with this fella? The sine cannot. The sine cannot swallow the angle, right? So you throw. Cannot swallow the sine, right? The stick. So throw the stick out. Like that. Okay. So that's all. If they test you in that way lah. Okay. So let's see. This fella has this negative here. Is tangent able to eat it up? Cannot. Throw it out then. Throw it out. Throw it out. Oh, throw it out already. This tangent is on its own minus p, right? So tangent is minus p. Originally there was a minus here, so it's originally is this fella being thrown out. This fella, I throw out already, right? Throw out here, there. Throw out. So this minus came from there. Then tangent x originally is equal to minus p. That's why final answer is just p. Finish. Okay. They tell you this question tells you x is obtuse. That's why there's a minus there. You see, we start from here, right? Down here will be ASTC. Down here will be acute, right? So obtuse means like that. So the right angle triangle will draw here, right? Okay. And then we are talking about this angle, right? Okay. Opposite over adjacent is minus p over 1. Okay, how do you know where the minus go to? This minus, right, can either belong to the numerator or the denominator. Who it belongs to depends on the diagram. Okay, so this is opposite. Is this positive? Yes, it's positive, so I don't put the minus here. Opposite over adjacent, right? This is 1. Is this in the negative region? Yes, then we put minus here. Okay, and this radius, this is actually a radius. If you draw a circle, right, this is actually a radius. Radius is always positive, so you apply Pythagoras theorem, you will get this. Okay, and from here we can try to do the second one. This first one, you don't need this right angle triangle, but later part sure need one, Okay, in your examination, surely you need to draw this. Okay, And when you draw this during the O level examination, they will give you marks. They're very nice. Okay, they give you marks. Okay, so how do I continue from here? Ayo, how can I take x minus 90? Cannot, right? Cannot, x minus 90 cannot. It's like just now that triangle I showed you, right? We don't take the small minus 90 ma. No, this one is less than 90, right? So we have to rewrite it in this form. Okay, I hope you get me. Take out the minus. Okay, then this must still be this. This times this must still be this. That's why there's a minus here. Now we are back in business. Okay, to get rid of this, you think this cosine monster can eat up the stick or not? The answer is yes. Aiyo, terrible mistake. Terrible mistake. Can eat up the stick, right? So cannot throw the stick out. Okay, cannot throw the stick out. Okay, so that is this particular part here. I can eat up the stick, right? So I don't throw it out, right? Okay, so that's all. Okay, now, okay, wait, this one is plus. Cosine of this is sine, right? Then finally, it will be, this answer. Because opposite over a hypotenuse is like that. Yeah, so no minus, no minus, no minus. It's just like that. Okay. Yeah, so you definitely need to draw this particular right angle triangle. Okay, that's all for this particular question. We go to the next one. Okay, you're asked to solve this. How do you solve this? Solve means what? Solve this equation means you need to find the unknown. Unknown is x, right? So how do you find the x? You use our very famous law called ADMAT. ADMAT, remember? Express it in the equivalent form. Is it in the sine, cosine, tangent form yet? Not exactly. There are other things, nonsense here that we don't want. So what do? We cross multiply. Okay, then we expand. We want sine x to be alone on the left hand side. So now it's not on the left hand side yet. So we are still doing the e. Like that. Okay, I plus 8 sine square x both sides. Then I minus 1 both sides. I get this. I divide by 8 both sides. I get this. Square root both sides. Okay, now I find my alpha. Remember, alpha, don't bother about the plus minus sign. Okay, it's always a plus. Then you press calculator. Wait, down here is the E done already, right? The ADMAT, the E done already. Now we check the domain. Domain, the X is between 0 to 360. Okay. Then M is the mode. What mode? Because it's in degrees, so it must be degree mode. Okay, now we are doing the alpha. Alpha found already to find SF. Okay, then the next A is the ASTC. Now, where is it, the angle? Where is it? You want sine to be either positive or negative, right? So it can be here, can be here, can be here, can be here, right? Because can be positive or negative for sine. That means all are acceptable. Okay, so the first answer will be this. Correct? Second answer is in this quadrant, right? But this and this same. This is alpha, this is alpha. Remember your butterfly? This is alpha, this is alpha. Okay, this part cannot forget. So the angle for the obtuse angle will be 180 minus your 37 point whatever. That's the second answer. Then this is alpha, right? This is alpha. This is 180, right? So 180 plus another alpha will be this angle here. And finally, 360 minus this alpha, that will be this angle here. Okay? Round everything to 1 dp because this is angle in degrees, and that's your answer. Alright? Okay. Well, I think we'll do one more. We'll do short videos, okay? Short ones. Because long ones, right? Some of you say cannot take it. Okay, so do one last one. They ask you to solve this, right? Solve means find the answer. Find the unknown. So because this is an equation involving trigo ratio, so we use our add-mat. Is it in equivalent form yet? Sine, cosine, tangent? No, it's not. So what do we do? Now, do not at this point in time change this to 1 over tangent or cosine over x. No, don't complicate things, okay? Keep it simple. You do this first. All the cotangent come together, all the number go together. Like that already, right? Then, like that, right? Then, you flip. As in, sorry, cotangent you change to 1 over tangent x. Then you flip. Okay? With single fraction you flip. Single fraction you flip. So now you have achieved your E already, the add-mat, the E. Now the next thing is the domain. X is between 0 to 2 pi. Oh, we know from the 2 pi that we must use radian mode. Change calculator mode now. Then next is your alpha. Okay, if there's a negative here, don't bother, just take the positive value. Press calculator, and then the next A is your ASTC. ASTC. Where is it? You see your tangent is positive, right? You write ASTC first. ASTC. That means you see, you want 0 to 2 pi, right? That's one full cycle. So it's here and here. You already know this is. Now you want this. Has to be this plus pi, right? Finish already, lor. That's all, okay? Now notice radian, angles in radian 3SF. Okay? Angles in degrees, not 3SF, 1 dp. Alright? Okay, we'll end the video here.